Hello, everyone, and welcome back to our vLLM Office Hours, our 46th edition. Take an extended break that I was not too pumped about, but I'm really excited to be back with everybody. We've been busy over the last month or so. Michael and I have been traveling a decent amount for a lot of meetups. Since we last spoke, we've been to Austria, to Poland, to Sweden. We had a meetup in Boston last week. Was it last week, Michael, or the week before? Last week, I think. The 31st.
Last week.
And then last night, Michael was in Knoxville, in his hometown. He still is, I believe, but there was also a meetup in Knoxville. So it's been quite a busy time for us. But we are back, and we're back with a packed schedule. So I'm really excited to join us, for all of you to join us today. If you don't know me, if you're new to these office hours, my name is Sasha Zelenovic, and I manage technical marketing at Red Hat. I know my name says vLLM Community, and that's because we moved over from the Red Hat Google Meet over to the vLLM Google Meet. And I was mentioning earlier to some people that joined a few minutes early that the transition, it's still happening. If you have any feedback, if you're getting too many emails or like you're just seeing something that's not cool, just let me know, please. We want to make sure that the sign-up process and the join process is as seamless as possible without too much noise on your end. So I'm really excited about today's topic. We get a lot of questions about multimodality in the vLLM, and here we have Han Gao, and he's joining us from China, right? It's quite late there. It's 2 in the morning. So we really appreciate the passion and dedication. Han is a committer on the vLLM-Omni project, so we'll do a big deep dive into vLLM-Omni. So please ask your questions. Get ready for a lot of good knowledge. We presented very similar slides at a meetup in Hong Kong that was really well received. So you'll get a good amount of technical depth into vLLM-Omni. But before that, since we missed a month and a half almost, Michael will have to cover 3 vLLM releases. So before I pass it over to Michael, I do just want to quickly mention the upcoming schedule. So we'll talk about vLLM-Omni today. As I said, next week, I know these are supposed to be bi-weekly, but we have so many topics that we're trying to squeeze a lot in the coming weeks. So next week, next Thursday, we'll give you an LLM update. There's a lot of good things happening in LLM compressor, so the team will join and do their deep dive there. 2 weeks after that, we'll share. We'll talk about vLLM performance triage. Really excited about this one. We'll talk about things you can do to remove some of the performance, or to analyze some of the performance bottlenecks. So you don't have to throw everything out the window and start fresh. We'll go by steps on the best ways to triage performance. You can get to the best that the vLLM is delivering. 2 weeks after that, we'll talk about agentic AI and the latest trends there. And then 2 weeks later, on May 28th, we'll be talking about vLLM on CPUs. And I know there's a lot of questions about CPUs. I know a lot of people will be excited about this one. Intel is seeing some amazing results, so they'll share their benchmarks and how to get started. All right, we have a packed agenda, 3 releases, vLLM-Omni. Michael, let's go and let's get started.
Yeah, thanks, Sasha, and really good to see everyone again. Glad we can get back to some regular cadences on this. Yeah, we have a lot to cover, and I'm happy to cover it. We're gonna maybe gloss over some model releases and a few blogs we've had, so I definitely recommend you check out, blogs we've been posting on Twitter, on the vLLM.ai website, and of course keep up with the projects yourself. But we're gonna cover a few after a brief introduction on what is vLLM. If you're not familiar already, it's the open source standard for production LLM serving. It's a very popular project, the most popular project for production LLM use. 75,000 GitHub stars. We merged over 2,000 PRs a month, a very fast cadence we're on these days. vLLM is deployed over millions of GPU hours every day on GPUs we have from anonymous telemetry. We have now 13,000 members on our developer Slack, which you're welcome to join and join in on the fun in the community. Over 2,500 unique contributors have merged code in vLLM. Many of those from major institutions, academic institutions, industry, and frontier model labs. The vibrant community is ultimately what powers a project like this. It's Apache 2.0 license, a Python-based library. It's meant to be very easy to use. So it's just a pip install away, and once you've installed, then a vLLM serve away to serve whatever state-of-the-art model on your very expensive GPUs. And the reasons why vLLM are so popular is because of that simplicity, but also because of its generalizability. It supports hundreds of different model architectures, and most importantly, the state-of-the-art LLMs on release when they come out. Running those models, of course, efficiently on NVIDIA GPUs, but also a dozen plus different hardware architectures through the hardware plugin interface. Then deploying those models across multiple accelerators at once with different types of device parallelism, either on a single node of accelerators or multiple nodes of accelerators, and then disaggregating the different compute parts of LLM inference and also the different modules of LLM inference, which I'm sure we'll cover a bit in vLLM-Omni as we have even more modules that we have to think about disaggregating. And of course, vLLM is actually more than just the vLLM package itself. It's a whole project ecosystem where vLLM-Omni is a part, where we have like LM compressor, as Sasha already mentioned, speculators for training speculative decoding models, LLMD, semantic router, all these sort of projects and more are ultimately under the greater ecosystem. So now I'm going to cover some blogs and releases we've had over the past month or so. First, I want to cover P-Eagle. We're really excited about this, as this is a new state-of-the-art form of speculative decoding, specifically a parallel drafting method to get multiple tokens out of the draft speculator in a more efficient way. Rather than needing to iterate through the draft model multiple times in order to predict n tokens, we can just go through the draft model one time, one forward pass, and predict multiple tokens at once, which we then verify through the model as we normally do for spec decoding. And this really improves throughput, both are really efficiency at high levels of throughput. So making speculative decoding be more effective, not just at very small batch sizes, but also at medium levels of batch sizes, which is critical for ultimately production inference and efficiency. Next, sorry, this title is a bit off. This should say Model Runner v2, which you can still see the Model Runner v2 blog here. This is a new, sort of rework towards the Model Runner interface in vLLM. If you're familiar with vLLM v0 to v1, this is kind of similar in aspect, although we're working on just the Model Runner and reworking completely how that structure works without affecting the front end or back end of vLLM. So you as a user shouldn't notice anything different except for speed and modularity in the library. Sorry, I'm just gonna mute you. Okay, yeah, got it. Thanks. We'll have questions at the end, so don't worry. And yeah, just here we have some great benchmarks that are really positive for particularly cases where we find we're CPU bound, like running a very small Qwen 3 model on a GB200. Not exactly the most realistic scenario, but a case where we see a lot of CPU bottlenecks because the GPU is just so fast at running this model, and we're able to see a 50% improvement in throughput thanks to reducing that overhead, and not to mention reducing the lines of code and complexity to implement the same functions. So it's still very much in development. I'll cover a few of the key features in the release notes. But yeah, look forward to this big project and refactoring effort. Next, the actual title of the previous slide. We have another blog on extracting hidden states from vLLM. This is a key feature for optimizing the training of Eagle-like speculators from vLLM. So I mentioned before, we have the speculators library for training Eagle or draft models. And vLLM is often used to generate the hidden states from the model. But previously, we had to do this in an offline way, saving the hidden states to disk kind of as a data set, and then pointing speculators to that. This sort of extraction method means we can do it with vLLM as a live server and not need to stage terabytes of hidden states on disk, and we can save them in a more incremental and live way with vLLM, and of course take advantage of prefix caching and other optimizations to make generating the hidden states more efficient. But then we can also extract these and transmit them directly through the KB connector interface, and skip storage entirely and just transmit it between process to process or GPU memory directly. So this is a big structural improvement we've added in vLLM and should give a great optimization for online speculative model training. Next, we had a big release with Google DeepMind on the Gemma 4 launch. vLLM was a launch partner for the Gemma 4 models, and I can confidently say it's the first time we've ever launched vLLM across NVIDIA GPUs, Google TPUs, AMD GPUs, and Intel XPUs, all on the same day, and all pretty much using the same model code in vLLM, which is a real triumph, I think, of a lot of the abstractions we've built in the project, and just great to see that we can put it all together. And I hope we can do it for even more model releases. Next, we have a great blog from the team at Anyscale. They've been working very hard on elastic EP and ultimately resiliency and fault tolerance for wide EP, wide expert parallel deployments of vLLM to build out their RayServe LLM product. And here they have a great blog I recommend reading if you're interested in wide EP. It just explains it rather well. And they talk about how they handle this fault tolerance, not just within EP from the elastic EP level, but also with various DP groups. And ultimately, what do you do if you're deploying a model across dozens of GPUs and suddenly one GPU dies? How can you keep the service running in a resilient way while that GPU is in recovery and rebalance things? So yeah, really interesting, in-depth infrastructure blog from the Anyscale team, and they're helping out with a lot of work here. Kind of last on the updates, I can't get away with mentioning TurboQuant. I work on, if you know me, I work on a lot of the quantization stuff in vLLM. So I've been working with the community quite a bit on getting this KV cache compression method into vLLM. We've had some very early integrations, basically one day after release, of people getting it working in vLLM through sort of plugins or various repos that are hooking into vLLM. And we're still working on integration for an in-tree, upstream integration of TurboQuant, so people don't need any other dependencies to run it. This PR 38479 is where we're currently working closely with someone from the community, and landing just that. And I'm excited to see how this hopefully powers research on how effective these KV cache compression methods can be and how low they can go ultimately. So yeah, now I'm going to quickly cover releases. As we mentioned, we've had 3 releases since the last proper office hours. First, starting with 0.17, almost 700 commits from 272 contributors, 48 of those new. Great stats we love to see. We had a lot. We had a lot of new model architectures. Qwen 3.5 was a major one. Several new ASR models, including Qwen 3 ASR with real-time input streaming. We added initial support for quantized LoRa, which is a great optimization for multi-batch LoRa. It finally integrated Flash Attention 4, coinciding with the paper release, which is great to see. We've added a Flash and First Sparse MLA backend to optimize for DeepSeek 3.2 and GLM5 based models. And we've been, refactoring the MOE structure in vLLM, most notably adding the MOE runner abstraction to further modularize MOE experts from MOE communication, from TopK, routers, and just trying to make more parts of our MOE kernels plug and playable. And we've also started integrating several kernels from the Helion kernel framework, which was just added to the PyTorch Foundation the other day. A big note on this release was the bump from PyTorch 2.10. So make sure you're aware of that. And as I mentioned before, Model Runner v2 is in very active development, and we added a lot of key features in there, including pipeline parallelism and maybe really importantly for performance, piecewise and full CUDA graphs. Weight offloading v2 landed, which is a key optimization that we used for GB200 disag deployment of DeepSeek 3.1. If you followed the blog on that a few weeks ago. And we added a new UX option, this sort of high-level performance mode, where the default is balanced, how vLLM is going to sort of choose CUDA graph sizes and choose kernels. It's going to assume you want probably a good amount of throughput. And we've added these new options for interactivity. If you want to go for low batch sizes, very high per user tokens per second, and throughput if you want to go for maximum tokens per second per GPU at very high batch sizes. And these are just really high-level modes that we want users to specify, and we can build better heuristics and rules within vLLM on how we're going to dispatch between them without you needing to tune 5 or 10 different arguments yourself. Hopefully we can build more heuristics there. Lots of Torch compile updates, especially with the Torch 2.10 upgrade. Most notably, maybe the ahead of time compile. This greatly improves performance on warm startup times when using Torch compile, so great benefit there. And of course, many optimizations for NVIDIA GPUs, AMD GPUs, Intel XPUs, CPUs. I mentioned elastic expert parallelism is seeing a lot of development and similarly released with the AnyScale blog, and some of those related PRs are there. And some API compatibility improvements. Next on 0.18, we again have 450 commits from 213 contributors, 61 of those brand new, a whole new suite of model architectures. I think Olmo hybrid is a really and Sarvam MOE are sort of the most complex ones within that release. We added online beam search for audio speech recognition and a GRP serving setup for vLLM. If you're interested in not using the fast API web server and instead communicating to the vLLM server with RPC, we have this new gRPC flag and interface. We also have a GPU-less rendering serving class now with vLLM launch render, so we can separate the multimodal processing from GPU inference for better disaggregation there. We've brought n-gram speculative decoding onto the GPU, so to make it compatible with asynchronous scheduling and, of course, reduce CPU bottlenecks. We've been optimizing KV cache offloading, making it more of a first-class citizen and offering native CPU memory offloading throughout more features in vLLM. And, of course, more development on ModRunner v2. We expanded Flash Extension 4 to be a supported backend for MLA prefills, and particularly are optimizing that for MLA prefill performance on Blackwell. A lot of improvements on AMD ROCm. Great progress there. Intel XPU added their ModelRunner v2 support, which is great to see that being adopted by more backends as we're continuing development of that. We added the first RISC-V CPU backend, which is definitely an impressive effort. Started the AMD Zen CPU backend through the new Zen Torch library. One keynote is we did remove Ray from the default dependencies of vLLM. It's still very much usable with vLLM, and we still have the Ray multiprocess communicator. It just hasn't been used by default, so we decided to loosen the dependency a bit for vLLM. Lastly, for vLLM 0.19, again, 448 commits from 197 contributors, 54 new contributors. We're really consistent on these now that we're releasing every 2 weeks. This was the release that had Gemma 4. We released a pre-built Docker for that across a variety of hardwares. We added the LoRa target modules argument to restrict setting up LoRa adapters on modules that you don't have weights for. This is a big performance improvement if you only have selective LoRa modules that you're trying to apply. We've had a lot of improvements to pooling or encoder performance in vLLM, basically a 50% throughput improvement by decreasing some CPU GPU synchronizations. We landed zero bubble asynchronous scheduling and speculative decoding, greatly improving throughput when using speculative decoding. We landed CUDA graphs in vision transformers, or rather full CUDA graphs for vision transformers with the attention backends there, which is really good for low latency. Again, developing the CPU KV cache uploading with more performance features and more extensibility. We generalized dual batch overlap, which is a key optimization for expert parallelism with models like DeepSeek across all models that can possibly support it. And of course, a lot more developments on Model Runner v2, keeping steady development there. A lot of work on Blackwell, optimizing for the latest B300 or Blackwell Ultra series. Several fusions and kernels landed in this release, as well as tuning attention kernels for that. We also had some specific optimizations for GPTOSS, including landing a custom router gen kernel, which is needed because the router gem is a particularly small, skinny shape, improving low latency on GPTOSS. AMD landed support for ROCm 7.2.1, which is big, and of course has been pushing performance a lot for MLA and DeepSeek-like models. Intel finally landed MLA model support. TPU landed support for asynchronous scheduling through the model pluggable interface to actually expose it for any pluggable hardware backend. And the CPU backend has had a lot of performance optimizations as well. We added the chat completions batch endpoint, limiting thinking tokens with a hard limit through the API, and many streaming tool calling fixes. Thank you to everyone in the community who have been writing up extensive issues and that we've been dedicated to squashing. And finally, we landed online MXFP4 quantization support, so you can quantize your unquantized checkpoints within vLLM just by specifying MXFP4 in the quantization argument. Thank you for letting me get through all that. And now I'll hand it off to Han to cover vLLM-Omni in great detail. Take it away.
Okay. Can you hear me?
Yeah.
Yep.
Great.
Okay. Great thanks to Michael and also Sasha previously for the invitation. Because right now I'm located in Hong Kong, it's a little bit late over the midnight, but it's also a great pleasure for me here to introduce some overview and details about the vLLM-Omni, which is a sub project for the inference and serving for omni-modality models. So that let's get started. And if you have any questions, you can just leave some notes here. Okay. Yeah. So before the introduction, let me first introduce myself. Actually, I'm one of the core maintainer in vLLM-Omni. We collaborate with some other maintainers, including Roger. Maybe most of you are already familiar with him. He's also the committers in the main repo, and also is also expert in inference from mainland China. And for me, I'm just located in Hong Kong, and so maybe most of you, according to the time zone, might be in America or in the West Sphere. So that previously, in the initial stage, I think that a lot of developers in Asia Pacific and especially in East Asia, but I noticed that recently a lot of developers in, for example, in North America have noticed this project and contribute a lot of PRs and important features. And great thanks for the attention and contribution. So next, I'd like to give a brief overview of this project and introduce some background and motivation, etc. So along with this picture, actually, if we use one sentence to say what it is, because previously, actually, the vLLM, mainly focused on the text generation. Even if you have multimodal inputs, for example, images or videos. But actually, if you use the features in main repo, in main VM repo, actually only will generate the text outputs, right? And so what's next? Actually, in the vLLM-Omni, we try to shift it to from purely text generation to heterogeneous multimodal generations. For example, the image, audio, or video, etc. Actually, if you know some typical models, actually, which are quite different from the pure LLM models, most of them are autoregressive architectures, but for the omni-modality models, they have heterogeneous modules within the same model, right? In general, maybe we can categorize these modules into, for example, we have encoders, right? We have vision transformer, whatever, to encode the inputs with different modalities. And of course, we have LLM cores, right? Most of them are autoregressive decoders, right? And then for the multimodal generations, we will have a new module, which is maybe diffusion transformer or ISTM or convolution, whatever, that can help to transfer the latent tensors into the final the modalities that we can see or we can hear, right? And so along with this characteristics, we have important abstraction, which is a stage, right? And for each stage, according to the specific modules that we can, for example, we can deploy them with disaggregately and optimize them independently to improve the throughput or reduce the latency, etc. So as for a framework, actually we have a lot of we already support a lot of features that can be improve the simplicity and ease of usage. For example, we similar to the main repo, that we can have a seamless integration to Hugging Face and also Hugging Face transformers, and also for diffusion part, we also have an integration with diffusers, right? If you know multimodal generation before that, diffusers is also a very important repo for diffusions. And of course, just like I said, we have a important abstraction in stage, and along with this abstraction, actually we can run them just like a pipeline parallelism, that each stage can handle the request independently, so that with this pipeline streaming, that we can overlap the computation to improve the overall throughput of multiple requests significantly, right? Because previously, compare with the for example, the Hugging Face transformer baseline, generally we can have 3 to 5 times overall throughput improvement. And besides that, for the different part, we also integrate a lot of important acceleration features, for example, about the sequence parallel, or about some cache optimization, especially for diffusion. That we already support a series of optimization techniques, and I will introduce a bit more later. Okay, and then we already have a plugin system design that can help to support the inference to be run in a lot of different hardwares, right? And so of course we have different places that you can discuss, right? In Slack, we have just in the VM, we have a specific channel which is Omni, right? If you have any questions, or if you want more people to talk about your issues or PRs, of course. And we also have a weekly meeting we have English version and Chinese version. You can choose one and choose a specific time according to your language background and your schedule. Yeah, that's the overview of the whole picture. Okay. And so along with this whole picture, actually, in vLLM-Omni, we try to support especially the omni-modality models. Because previously some people or some developers asked, okay, so if a specific model can be supported in vLLM-Omni or vLLM, I think that there's a very simple standard that if the model only generate text, I think it should be put in the main repo. But if it is generate, not just the text, but audio, video, or image, I think it's a better choice to put it in vLLM-Omni. For example, there's a task called ASR, right? It's audio speech recognition. So it's better to put these related models into the main repo. There's also another related task, which is TTS, right? It's text to speech. And currently we have already supported a lot of SOTA TTS models. For example, the Queen TTS or Voxtro from Mistral that already supported in vLLM-Omni. Yeah, and I hope that can make you more clear about this. Okay, and so actually model outputs, and the second one in terms of the model architectures that not just the autoregressive, which already well supported in main repo. We try to extend the support to some other heterogeneous architectures such as different transformers or LSTM or convolution, whatever. And then the third one, of course, is the heterogeneous outputs. Just like I said, that this is the main scope of this repo. Okay. And before the more system details, maybe that at the beginning, let me introduce some basic usage, right? Actually, it's really simple. We try to keep the consistency with the main repo. For the offline, that we will have an entry point, of the main class, which is Omni, that you can just initialize a certain model with a Hugging Face repo ID, right? For example, there's a one important model which is I
think we lost Han for a second. Are you here, Michael? Can I hear you?
Yeah. I think he might have dipped out. Let's give him a second.
Are there any questions from the chat that you want to address in the meantime, Michael?
Yeah, sure. From Arabindo, can we have one vLLM to rule all modalities? vLLM just runs the models. We still need someone to release an open source Omni model that's really good. Luckily, we've seen a lot more of them, especially from the Quen team, Quen 3 Omni, Quen across their weight dimensions too much. But I do think it'll be a more interesting question as the draft models maybe become more complex and push more compute for some of these like parallel drafting methods like Eagle I mentioned, but what I didn't mention was dflash, which landed recently, and will probably bring more compute that will want to good question across since parallel ranks. I'll hand it back to Han now that he's back. Can you hear us? Yeah.
Yeah. Sorry.
Be able to get back a hold of it.
Okay. Sorry for the interruption. Yeah, thank you. Yeah, let me continue. And just now I introduced the main repo. Here we have Omni that we can initialize some different kinds of models, and then in the flying inference scenario, right? And this also that you can have image generation, just use the similar logic, right? But of course the name is a little bit different. And the second one is about online serving. Actually, we also have a fast API based server for it, and for the online API server initialization, is quite similar to the main repo. Here we use vLLM-Serve, right? A certain model, and the only difference with this one, it can tell the inference engine, okay, that we need to use the API server going to the vLLM-Omni, not just from in the main repo. And along with this API server, we can support almost the same, right? We can send the curl request or Python request, and with the fast API or OpenAI API format, right? Here we still support the chat completions, and besides that, actually we can for some different model, more frequently used in the multimodal generation. Okay. And time, we can just print the output just in the terminal, right? And you can see, okay, so what's the output of the plain text. But for to understand what's going on, and we currently already integrate a lot of different kinds of and also for example, if you use a multimodal generation for the graduate demos, or commonly used, that you can submit or the image you want. You can just in the web page, you can see the outputs, or you can listen to the audios you generated to see if it is correct or not. And another one is a Comfy UI, which is also a very commonly used low code pipeline that you can combine different kinds of models that to implement a specific function. That currently already supported. And third one, of course, is a vLLM Playground. It's a web interface, can help the users to better interacting with the current vLLM or vLLM-Omni servers. Okay. Okay, yeah. Let's move on. Yeah. And actually, vLLM-Omni, just released last year in the December 2025, and then till now, actually, it already supported over 40 popular Omni and different models. And it's keep growing rapidly, and we already have a lot of cooperation with different, big models, repos, models community. For example, the Queen, we already support the Queen Omni series, Queen Image, and also One, which is a very popular video generation model. And with Mixtral, we day zero support the Voxel TTS, which is also a very high performance text to speech generation models. And also we support some, for example, Bagel. Bagel is a important comprehension and multimodal generation models from ByteDance, and we have Hunyuan Image from Tencent, etc., and also Flux series. And we truly welcome more contributors. If you are interested in some certain models, you can help to integrate them into the framework. And we are also looking for the valuable feedback from all the users that if we can better integrate different kinds of models more easily. And currently, actually, because the repo, just released maybe 4 months ago, I know because currently in the inference or in the agent era, it's everything changed very fast. But till now, it's still a very new and growing project. And so that we thanks all the contributors who raise issues or participate different kinds of discussions, and hope to welcome more contributors, especially that's why today it's over the midnight in Asia, but I hope that maybe more friends in the West sphere or in North or South America, that you can, if you have interest, you can join the discussion or contribute or use it to give some valuable feedback. Okay, thanks. And as for the installation, I think it's also very simple because we have a dependency for the vLLM main repo. So we have a consistent version number with the main repo. For example, recently we released the formal version, which is 0.18.0, which is also match the vLLM. We have the same version number, so that you can just install the vLLM first, right? And then you install vLLM-Omni, that you can use the supported features. And after the official release last year, over 4 months, we have over 4.2 thousand stars, and I think that we receive a lot of attention among different areas or communities. That I hope that along with all the contributions from all of you, that we can keep growing in the future. Yeah. And so after the whole overview, I would like to introduce more details about the system design, and along with this walkthrough, I hope that first of all, it can help you to understand how what's the input and what's the output, right? How vLLM-Omni processes a multimodal request and generates its multimodal outputs. And the second one is that if you want to deploy it into your specific application scenarios, or maybe you have to modify some part of it, that in this walkthrough can help you understand, okay, what a certain design or certain function maps to what kind of which part of the code. Okay. Before that, actually, because for inference framework, we have to the first question is what kind of models do we support, right? Because after all, for the inference framework, we need to run different models, right? Just like the release notes introduced by Michael, for each version, we will support different important models. So for vLLM-Omni, the question is the same, right? So what kind of models do we support? Different from the pure LLM, generation models, the omni-modality models, have a lot of variance. In my view, it haven't converged. And so in this paper, actually for vLLM-Omni, we already, post the archive paper. And, if you have interest, you can read inside. We generally, we can categorize them into maybe three main types. For example, the first one is Queen Omni series. The main difference is that it does not only have one autoregressive part, but it had multiple ones. Here it has a thinker, talker, and video and voice generation part. It's something like the thinker is just like a pure multimodal comprehension model. You can regard it as a Queen VL, right? And I receive a lot of different kinds of multimodal inputs, and then to generate a text or the embeddings and the prefill embeddings. And the second one is the talker. Talker is still autoregressive, and this is the largest difference compared with the pure LLM. And just like thinker is just like a human brain. It helps you to understand the information received from the outside, and talker is just like human mouse, right? It help you to generate some emotional information or tones that with this latent tokens that in the voice decoder, it can help generate very consistent and natural audio. Will help to better interact with the users. And the second type of the model, which is it's like a combination of autoregressive and diffusion transformer. There are some typical examples, for example, the Queen image or GR image, which is also a SOTA model just released this year with the prefill computation and decode computation, which can be as a condition to help to instruct, to guide the denoising process of the image generation or video generation. So if you know more background about the different models at the beginning, actually maybe you heard of stable diffusion, right, which is a very famous model series. At the beginning, actually, for text part, they only use clip. A clip is just a very simple and efficient, contrastive models that can help to understand the text input and then to guide the denoising process. But the clip, is very, very small and no much space for inference optimization. But here, because along with the model, the evolution of the model, actually the autoregressive part becomes much more heavy compared with the previous time. So that's why that is a good opportunity here to combine with the current optimization in the main repo for autoregressive with the diffusion transformer part, that it can unify optimization for both comprehension and generation. And the third part, is, I think it's more like a trend for the development of the future models. Actually, here there are some typical examples, which is, for example, Bagel and Hunyuan image 3.0. I think these we can call them as the unified comprehension and multimodal generation models. For example, here is an example from Bagel. It has autoregressive part, right? Maybe it can receive multimodal inputs and do some understanding, and then it has a shared KV cache values layer by layer. It can help to instruct the denoising process. So here it will have a large KV KV value transfer, just like for example, just like the PD disaggregation in the large language models. Here, what the KV transfer is between the autoregressive part and the diffusion part, right? And then for a Hunyuan image is also a little bit different. It has a single suite of model weights, and with same model weights, it can do the autoregressive decoding, and it can also do the denoising process. So the same weights and two computation formats, it can do it at the same time. So that of course these kind of models becomes bigger and bigger because it can do the unified comprehension and generation. Compared with previous different models, maybe for example Hunyuan image 3.0 has been 80 billion parameters, which is pretty large compared with previous different models. And so of course here's a very natural question is because the multimodal generation, receive a lot of attention from different developers or users. The why previously the VM, haven't support the multimodal generation. I think there are a lot of reasons. In my view, there one of the main reasons that in terms of the memory or the computation or the some other aspects, there are a lot of difference among with autoregressive and other modules such as different transformer or STM. I think different transformer is a very representative architecture that has a lot of difference compared with autoregressive. Here, for example, the generation process, is for autoregressive. I think all of you know that it's token by token, right? Condition on the previous token to generate next tokens. So that's why that you can use KV cache, and you can use. That's why we have page attention, which is of course is one of the core innovation in vLLM, right? But for a different transformer, it's totally different as oh sorry, how to okay, that's right. For different transformer, it has a fixed length of tensors. It can be computed step by step, so that the length is fixed. It will not grow token by token, so that for the original KV cache or page attention, is useless. And along with this, the bottleneck is also different, right? For autoregressive decode, with KV cache, so of course it's a memory bound, right? With the increase token by tokens that it requires more memory. But for different transformer, it's more like a computational bound, right? If you specialize maybe 1 or 2, your GPU computational usage is already near 100%. So maybe it's you cannot receive a lot of gains with batching, right? For example, in autoregressive, we have continuous batching. With large batch, you can increase overall throughput, but for different transformer, if you increase the batch size, maybe you cannot receive a lot of gains, right? And we also have some other differences. For example, the attention mask, right? For autoregressive part, you have causal mask, but for different transformer, you have bidirectional full attention mask. So along with all this difference, that's why previously the VM haven't support the multi-modal generation part or different transformer part, right? And also for parallelism, there are also some differences. For different transformer, more frequently we use the sequence parallel. For example, the Ulysses parallel or classify free guidance parallel or ring attention. All these are more frequently used in different scenario. Yeah. And so,
Hey, just Quick time check, Han. We're coming up to an hour, but we can totally stay longer. But just so you know, we're coming up to an hour in about 2 minutes.
So how much time left? Can I have?
So we usually have 2 more minutes. We end on top of the hour, but I'm sure people will stay longer. So you can keep going.
Oh yeah, maybe I can yeah, accelerate. Yeah.
Like sure, yeah, 15 or 20 minutes.
Oh, fine. Thank you. Yeah. So maybe yeah, let's continue. Yeah. So along with this background, actually here for vLLM-Omni, actually we hope that first of all it can inherit the main features from vLLM main repo, that it can extend the have a flexible extension to different kinds of architectures. So here, if you are familiar with vLLM, actually from up and down, you can you are familiar with all these modules. For example, we have API server, and also for autoregressive, we have LLM engine, scheduler, executor, etc. Right? All these we inherit and make some modification, but we also have some difference, especially in the entry points, because here is that we, along with this stage abstraction, that for different kinds of model stages, right? We will have stage client, which is a abstraction. Actually, here at the beginning, it's a little bit different, but recently we have large-scale refactoring. Is that we try to match the concept level of the main repo, which is engine client. Engine client is a very important abstraction in vLLM, so that we have an entry point class for Omni and sync Omni for the online serving scenario, and also we have an orchestrator who works for the runtime pipeline for multiple stages, and also we have stage client. We have different kind of stage client. For autoregressive, we have stage core, engine core client. For autoregressive, we just a subclass inherited from the engine client in the main repo. And for different part, just like I said, it's a lot of difference that we implement the different engine core from scratch. For the scheduler, worker, model runner, it has similar concept level with autoregressive, but in the specific functions, it has a lot of difference. And also beside that, we have Omni connector. Same thing, it has it's a similar concept, such as Kiwi connector in the PD disaggregation, or EC connector for EPD disaggregation. But here, we hope that use Omni connector, it can support the communication, data transfer among different model stages with a heterogeneous data type, right? Due to the time limit, I will not go into the more details. This one's a hardware plugin system that with this hardware plugin that the developers don't need to care about specific hardware details, and then you can integrate a lot of different kind of operators or hardware specific implementations in the model runner or worker part, right? I will not go into too much details into it. And of course, this part I need to spend some time, is that it's about the entry point refactoring. Is that from left to right, right? At the beginning, for offline inference, we have Omni class, right? And for online inference, we have API server, and then we can have a sync Omni, and also we have along with this that we have a sync Omni engine, which works for the stage initialization, and then within the single process we have multiple threads, and then we have orchestrator who works for the coordinator, and also the management of the runtime pipeline. And then for different model stages, we have stage for autoregressive, we have stage engine core client, and we also have stage diffusion client who will run the engine for in an independent process. That for example, for the LLM, which is engine core, and for diffusion is the diffusion engine that it can be run and optimized independently. Yeah. Okay. And it's also some details. I will not go into too much about it. And also, this is also an example that because we have different model stages, and so we will have a config YAML file that for different stages, what's the specific setting for this module, and also some engine args that that works for the specific stage, so that we will have a single YAML for different models to define and set the different input arguments. And for this part is that because we have the stage abstraction, we can natively support the disaggregated serving that different model stage can be deployed in different device or even different nodes, so that we have Omni connector, which can help to transfer different data that in different ways. For example, we can support the D2H to D, or we support D to D according to if you want to transfer KV cache values, or you want expression to transfer to support different kinds of needs for data transfer. Yeah. Let me show how to remove it. I don't know how to. Okay, that's right. Okay, yeah. And also, here's an example that with Queen Omni models from Thinker to Talker to Code Wave, that each stage it can be run independently. I don't know when the requests come in, and we have an input processor, and then you do the thinker part and talker part, etc. With multiple requests and second request, it will not hindered by the later stages. So the thinker can process the second request after the first request finished. And so that along this way, just like a pipeline parallelism, that you can improve the whole throughput of multiple requests significantly. Yeah. And this is also a very important feature, is about called a sync trunk. A sync trunk is just like, try to help the model to support the streaming output, because in audio generation, the streaming output is also very important. For example, if you ask a model a specific question, you don't want to receive the response after the whole whole output generated. For example, after 1 minute or 2 minutes, you receive the response. That is a disaster. So along with the sync trunk, we compute a single trunk for the first stage, and you will be transferred to the next stage instantly, and then you can receive the first trunk of generation just maybe half a second or 1 second after you ask a question, that you can interact with the model just like you are talking with a person, very naturally. So that's why we need such an important feature, and we have a lot of PRs to support it. Yeah. And yeah, there's more details. I will And then these are some statistics, right, for Queen Omni, that with a sync trunk that we can improve the TTFP. It's not TTFT, because in audio generation, we generally use time of the first pocket, right, to measure, how much time we need to wait to receive the first pocket. Yeah. And for text to speech, there's an important Queen 3 TDS that we will have over 8 times increase along with the sync trunk about the TTFP. Yeah. And also we have important metrics called RTF, which is a real-time factor to measure if it can support the real-time interaction. At least it need to smaller than 1. It means that the time you generate the audio to divide it by the time you wait. It means that if it is smaller, then it means that you can support the real-time interaction. Yeah. And for large-scale deployment, currently we have a PR is working on how to support to deploy different stages into multiple devices. For example, for the first stage, you can deploy it in two devices, and for the second stage, maybe it's heavy, so we can deploy it into more devices. So currently we try to support just like a PD disaggregation style. We use single CLI and can deploy a certain stage in different devices to support the large scale deployment. Yeah. These are some feature support, the current state of the feature support. Yeah, for certain model, if certain feature have been supported or not. So that's really welcome. More contributors that if you're interested in support certain features. And for diffusion part, just like I said, there are a lot of different acceleration features. For example, the sequence parallel about the ring attention or Ulysses, and also we have specific quantization support. For example, FP8 or GGUF, whatever. That we also have. Maybe I just ignore this. We have a table. Currently, we have a feature, statistics to show, if a certain feature or certain combination of different features have been supported for a certain model. So if it haven't verified or supported, then if you are interested in, truly welcome to make a contribution. Yeah. And also for the video generation or the audio generation, here is different from the speech generation. Audio generation is just more like artistic creation. Yeah, and for these kind of models, for certain kind of acceleration methods that if it haven't supported, there are a lot of spaces here. Yeah. And here's a brief summary about the above parts. And first of all, is is vLLM-Omni is support omni-modality models, and also for the usage and API design, we try to keep consistent and with vLLM main repo, and with stage abstraction, we natively support this aggregated deployment, and also along with this abstraction, we can run them independently to support the pipeline sync streaming. Of course, use a sync trunk feature, we can support the streaming output for audio generation. And also for diffusion part, we natively support a series of acceleration techniques. And also for roadmap, actually for the version release, here we have two kind of versions, which is the first one is RC version. It will maybe day zero. Generally, we will day zero support release the RC version after the formal release of the main repo. Just like a pre-release to let the users can try the latest features already updated in the main repo. For example, here recently, just last week, we released 0.19 RC1. Which matches the VM 0.19.0. And for formal version, generally every 4 weeks, we will, release some new features, especially in vLLM-Omni with sufficient tests and verification. Yeah, and currently we have 0.18.0, which is a formal version. Yeah. And of course, for community collaboration here, besides hardware support, we are still working on the RL integration. Just like VM can be a rollout engine for RL training, and for vLLM-Omni, of course, naturally can be a rollout engine for multimodal generation RL training. So currently, we already support initial PR to Virtual, which is also a very popular RL training open source project that can support you to do the GRPO, flow GRPO training with Queen image model. And also we are working on trying to integrate the diffusers as a backend, just like transformers as a backend on VM main repo. And also you can check the latest Q2 roadmap for phase 0 and phase 1. And I will not go into too much details. Yeah. And of course, the last one is, if you have more interest, we have Slack and GitHub, or if you use WeChat, we also have WeChat groups. And that's all of my sharing today. Thank you. Yeah.
Yeah, great work.
Oh, Michael, you're seeing this contest again, buddy.
Yeah, because a little bit late, maybe for myself it's a little bit fuzzy, but it's okay. Yeah.
Yeah, can you hear me now? No.
Yeah, I can hear you. Yeah.
We can hear you, but you sound like a robot again.
Oh, you mean my internet is a little bit unstable, right?
No, you, Han, we can hear you perfectly. It's Michael. It's Michael that's having some
it's
issues.
Michael. Okay. Yeah. My Michael's voice is like a robot. Yeah.
He'll be back in a second with good audio, right, Michael?
Yeah, hopefully. Yeah.
There you go.
Yeah. Thanks a lot to Han. You gave a great presentation, and yeah, you and the community are working so hard on the project. It's like miraculous progress, and very, very active. So yeah, it's yeah, I mean, just wonderful to see the work in vLLM-Omni, and yeah, hopefully we're even better prepared for the next state-of-the-art series of omni-modality models coming from the big model labs. So yeah, I hope that was enjoyable for everyone, and you learned a lot, and hopefully want to contribute to vLLM and vLLM-Omni now, and let us know if you're using it and have like feature improvements or things you'd like to see, or have issues. Sure, yeah, let's take one question if you have your hand up.
Cool, thanks, Michael. And Kosela here. I just want to say thanks to Han, because that takes a lot actually to be awake at 2 and present. I had 2 questions. I'm already part of the Slack channel. The first one is there any plan or any integration with inference engines, orchestrators that we know of, obviously vLLM production stack or LLMD, in order to sort of do LLM serving for multimodal models at production, as opposed to just the vanilla version of Omni. And the second question is another integration question related to open, more like a web UIs to try vLLM-Omni, because so far I know there's a Gradio and there's also a vLLM playground, right? And CompUI integration, but I was thinking more around different web UIs, like open web UI integration. That would be very nice, because people already use it, massively for autoregressive type of workload with the usual LLMs. And that's the kind of the question I had. It's like if there's any plan or collaboration right now currently to integrate vLLM-Omni with the other web UIs available for the community.
Yeah, I can answer the first one at least quickly. Like, yeah, we have plans and are actively working on like LLMD integration and orchestration for vLLM-Omni. It makes a lot of sense, especially when you're managing and scaling down the different disaggregated pieces and pipelines. Yeah, we think that's a great use case, and I think there's also talks with other distributed inference frameworks to, yeah, build sort of similar things. Yeah, I'm not sure about open web UI for multimodal or omni-modal, but I definitely think our understanding is like Comfy, Comfy UI is like the most popular thing for ultimately like image generation, video generation, these things. So I think that's maybe like the one to focus on. But yeah, I don't know, maybe Han, you know more.
Yeah, I think it's a good suggestion. Yeah, maybe we can think about it in the recent roadmap. And if you are interested in contribute, of course, you can leave a comment. And previously, because just like Michael said, yeah, the Comfy UI is more widely used, especially in multimodal generation, that you can combine different models to improve a certain, to implement a certain function. Just to use drag and you know, drag different modules, and then you can implement. And from web UI, I know it's more widely using LLM, right? And so maybe we can support it in both sides to implement the features needed by the multimodal generation. Yeah.
Thanks. Having used CompUI myself, it's not, there's like a learning curve actually to play with all the nodes and get with the perfect pipeline to generate videos, as opposed to, you know, when we use GPT to generate an image, that there's like a whole different use case where people just want to generate images or videos. I'm not saying stupidly, but like in a more straightforward way, as opposed to having a whole sophisticated pipeline. So I believe there's still a need for web oriented image and video generation, and that would be super nice to have a vLLM-Omni integrated with any of those web interfaces for sure. But thanks for the answer. Good talk.
Thank you. Yeah.
Yeah, thanks a lot for the question, and yeah, the discussion in the chat too. Yeah, we'll leave it there. Thanks everyone for staying with us through extended vLLM office hours. I think it was very much worth it. A lot of great stuff. So
see you
yeah,
next
take
week.
care. Yeah, and we'll see you very soon. Yeah, have a good week.